Yeah, just give me a minute real quick.
Yes, yes, you may take it.
All right, I'm back.
Okay. So, remembering the previous class, our morning class, so we'll plot a box plot. So I think we have solved the sum. I'll just open the board. Okay. So I think that the sum that we have solved in the morning, it's Q1. It's it's Q1.
Mm-hmm.
It's Q1 was 6.5. Q3 was 11.5, right? The things that I remember. And its upper fence was -1 and its lower fence, upper fence, no, I'm writing UP, upper fence, and lower fence was, I think so, 19. So now, how we'll plot the box plot? So here comes the x-axis. Here comes the x-axis. Okay. So for suppose this is -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Points should be visible. 8, 9. And for suppose I take dot, 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 19 here. Okay. So how will it look? See, we have to extend this line. Okay. So where the Q1 is, Q1 is 6.5. So the first line comes here, the box that we are going to plot. The one side of the box comes here, 6.5. And for suppose 10, 11, and for suppose 12. So the 11.5, the second side of the box comes here. And then we complete the box. Means one end of the box. One end of the box is Q1 and the other end of the box is Q3. Okay. And this the box has a line. Okay, has a line left side also. So this the line is called as the upper fence. This end of this line is called as the upper fence, and there's a line on the right also. So this is called as the lower fence. So all the
Shouldn't it be
data.
opposite? That's a
Sorry, sorry. Yes,
should
yes.
the upper
Lower
fence?
fence. Sorry, lower fence. Yes, correct. Lower fence and upper fence. Yes, good, very good. So the all the values below it are treated as outliers. Outliers.
Mm-hmm.
Outliers. Okay. So this was how to five number summary. How to plot a five number summary. Okay, so this is how that he has given how to plot a box plot. Next, I think, shall we discuss this example? And one more thing I left, sorry, one more thing I left. We have to show one more line inside this box that's called as the median. And I think median was around, what was the median? Do you remember?
The median was half of the box.
Yes, median is half of the boxes. So I think so. It was 8.5, I think so. We need to,
But it was 9.
it was 9. Okay, okay. 9, 9. Okay. So the third line would exactly come here. That three lines should be visible in this. And this line is Q2. That's also called as median. Okay, then we have completed the case. Okay. So now we'll move on. Okay. So we shall discuss this example. Come on. What we'll do directly, we'll take the values and we'll start plotting the box plots. Okay. So some students purchased pumpkins for a carving contest. Before the contest began, they weighed the pumpkins. The weight in pounds are shown here. So it is shown here. Make a box plot. Explain why median and IQR would be better choice for summarizing the center and variability of the distribution of a pumpkin weight than the mean and standard deviation. Okay. So we'll explain it. First, we'll make a box plot. So what I'll do, sitting and calculating Q1, Q2, and IQR, I'll take the values from here. Okay. So this is the data. This is where he has solved it. So I think Q1 is 4. Q1 is 4. Okay. What I see here is Q1. Q1 is 4. Median is 6.6. 6.6. And Q3 is 12.7. Okay. That. So this is the case. 12.7. Okay. So what is the lower fence and upper fence? And we find, we'll do that, lower fence and upper fence. How do we find? That's IQR equals to Q3 minus Q1. First, we need to find the IQR. So it is 12.7 minus 4, which is around about so
1.7.
8.7. Yes, 8.7. So how we'll find the upper fence? Upper fence is very compulsory. So it is 1.5 plus,
8.7 times.
sorry, yes, 12.7 plus 12.7.
No, 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 no. It's 8.7. 8.7 times 1.5 equals to a value. Value
See,
plus
1.5
Q
into
plus.
IQR. See, 1.5
Yeah.
into IQR we do. And for upper fence, we add Q3. And lower fence, what do we do? 1.5
We
into
subtract the thing.
and subtract Q1. Yes or no?
Yes.
So what's Q3 here? It's 12.7 plus 1.5 into 8.7. And what's
Mm-hmm.
Q1? So it's correct now.
4.
Q3 is 12.7 and 4 minus 1.5 into
8.7.
8.7. Correct. And now we'll use word mass. We'll multiply it first and then add it. Multiplication is to be done first. We cannot add first here. It will be wrong there. We cannot subtract first. Okay. So I'll see what is the calculation. So it's 1.5 into 8.7 plus plus 12.7. So it's 25.7. 25.7,
0.75.
well, yes, 25.75. And the next is
And that will be negative 9.05.
1.5 into 8.7
I put a
minus,
9.05.
it's minus 9.05, minus 9.05. So we need to take the values on the graph. Okay, so what I'll do, summarize it. I'll take a big scale. I'll start from, I think, minus 10. Okay, and take a interval of minus 5 here. Minus 5, 0, 5, 10,
Mhm.
15, 20, and 25, and it's 30. So minus 9.05 will be near about this line. Okay, this is the upper fence. Okay, and where is the Q1? I think it's on 4. So 4 is here, somewhat about here, and this is my box going till 12.7. 12.7. So 12.7 will be somewhat in the middle. Okay, and then this line going till 25.25. Yes, right. And what's the median? I think so. The median was, I've written 6.6. Okay, so it's 6.6 near about here. See, this is how will this Q1, Q3, and this is Q2. It doesn't means that Q2 will always come in the middle. It can shift towards the left as well as shift towards the right. There's nothing.
Yeah, it can't always be in the middle.
Yeah. So
I
see,
mean, sometimes.
you have told opposite. It is not compulsory that it will be always in the middle. Yes, it can shift towards the left as well as shift towards the right, depending on the distribution
Eh,
of the data. Okay?
it has to be in between Q1 and Q2, so it can
No,
never.
no, it is not. I'm writing it. It is not compulsory. It is not compulsory that Q2 is exactly in the middle of Q1 and Q3, but it is in
Yeah,
between.
that's kind of
But
obvious. It means it,
yes,
but it has to be between. Yeah.
yes, but it is between. Yes, yes, that's I got your point. But it's between Q1 and Q3 every time, every time. Okay. So he has given the answer for the next question. The distribution of a pumpkin weight is skewed to the right. Yes or no? Why skewed to the right?
Yes.
Because if we plot 2 points, there are 2 points in the data. When we will look here, see here, there is an entry 33, 31. Okay, 33, 31, and no more. Okay, there are two things, 33 and 31. So if I take a 35, there will be 31, one data point, and 33. So this shows you that these are the two data points that are the outliers. So box plot is widely used means the first thing that all the data scientists prefer to see the outliers is the box plot. Data box plot is also known as measure of outliers. The best measure of outliers, outliers in the graph, in the form of graph. The first technique in the form of graph is known as to be outliers. The outliers become the data points becomes very clear which are outliers and which are not. Okay, next. The skewness. Please remember, the skewness tells us skewness means skewness. Skewness
Skewed
means
to the right.
the skew to the right, skew to right, or skew to left. It only tells us it only tells us whether there are there are outliers outliers whether there are outliers or not, and on which side and on which side, but 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 cannot give us the data points which are affecting the skewness, which are outliers, which are outliers, which are outliers. Okay, so what does box
I'll
plot?
get. Yeah, give me 1 minute.
Okay, I'll give you this.
Okay, I'm back. I'm back.
Okay, that's good. So this is the thing. And box plot directly shows directly shows directly shows which point which data point is an outlier in that outlier. Got it?
Mhm.
Yes. Now we'll move on to the next topic. Okay, so okay, we have to read it as you were suggesting because okay, skew to the right with two higher outliers because the mean and standard deviation are sensitive to outliers. He has asked a question here. It's a very good question, I think so. Very, very good. Explain why the median and IQR would be a better choice for summarizing the center and variability of the pumpkin weights than the mean and the standard deviation. So you can see that Q1 at Q2, comma Q3, both of these three. So IQ4, IQR also comes from Q1 and Q3. So all these four are the resistance. My question is, are they resistant? Yes or no, Zaid? You have to tell me.
For the IQR, no, they're not
Or
resistant since they can change.
no, 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 they are resistant, right? We have studied this Q2 median. Median is resistance,
But
yes or no?
the yeah, but
Median,
if you add an outlier, then the
it doesn't change
Q.
drastically. Doesn't change,
Oh,
doesn't change drastically. The
yeah.
drastical change.
So
Okay,
so
that's the
it
reason.
is
I'll give one more
resistant.
example. If I am the,
Oh,
if
okay.
from your point of view, you are correct, but you have not seen many examples. That's the reason you are telling that it's not resistance. For example, my data is two. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. I'll take 9. So what's the median? My median is 2. Okay, what will be my Q1? It will be 2. What will be my Q3? It will be 2. Yes or no?
Yes.
And my IQR will be 0. Okay, first suppose. So if I first suppose I'm adding 200 on the right side. Yes or no?
Yeah.
I've added a larger quantity, which are outliers. Increasing the points generally does not increase outliers, but a value which is greater than from all the other observations are outliers. So hundreds is an outlier. So now measuring the median 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I think the sixth value 1, 2, 3, 4, 5, 6. This is the median in this case. Median is equal to 2. So this is my first point. Middle of this 2 will be Q1. So 1, 2, 3, 4, 5, 6, 6. So fourth, third, and the fourth. The average of both two will be Q1. So my Q1 will be 2 plus 2 upon 2, that's 2, and Q3 from year to year. So 1, 2, 3, 4, 5, 6. Okay, so third and fourth, the average of third and fourth. So again, it will be 2. So can you see there is any change in it? Yes or no? Is there any change?
No.
No. So
No.
for suppose I'm now adding the outliers to the left as well. Okay, so what I'll do is minus 100 and comma minus 100. So again, if you count here from here, my median will also be median. I'll write it here. Median will also 2, Q1 will also be 2, and Q3 will also be 2. I know that if data points increase, if there is 3, 4, 5, 6, 7, 8, 9. So if it's going to increase. Likewise, hundreds, 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 hundreds. See, 100 is increasing more and more. So what will happen that median will shift to the right. Median will shift to the right. Not drastically. Change will not be drastic, but small change in the form of data points. In the form of data points. So this is the case in case of median. So these these things these things these all quantities are resistance. Please remember. Okay, I've given you an example. Now it's clear, Zaid? Yes. See here for changing the median. See. I'll explain you one more thing. Here what we have seen with an example. See here. We have taken this example. Okay, see, when I have added, see, for example, consider this case only. This from this 2 to this 100. What was our previous median? Previous median was 2. Okay, when we added the 100, so median was 2, and then also the median was 2. But what was previous mean? If you calculate the previous mean, it would be 2 plus 2. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9. This was 9 to the 18. 18 divided by 9, it's 2. So mean is also 2. But now what happened? Just adding of 1 point. Adding of 1 point, what it does? So it was 18 plus 100. So it is 118 divided by 118. It would be 10 data points divided by 10. So what it happened that it became, the mean became 11.8. So see how drastic change it came upon just by adding one outlier. Yes or no? There is any change in the median here, right? No, correct? So there is no change in Q1, there is no change in Q2, there is no change in Q3, and there is no change in IQR also. But with
I know,
addition of
but there's a change in the mean.
but there is a change in
That's
the
what I
mean.
meant.
So mean is not
Yeah.
resistant, but Q1, Q2, Q3, and IQR are resistant. That okay, that's good. Okay, so he has given one exercise here. You can do it. Okay, try it, huh? Try it. Inshallah, probably. What day is there today? What is the day there today?
Friday.
That's
Friday.
Friday today. Okay, tomorrow, in both the sessions, we'll solve all the examples of this chapter. Inshallah, we'll try to solve the major and the most difficult examples from this book. Okay, so what he has given here, the question is. uh, Apple and Samsung. Okay, here there are two observations of Apple and Samsung. We have to, what do we have to do is to uh, plot the two box plots. What he has given the question is the overratings of the tablets produced Apple and Samsung are given here along with parallel box plots and numerical summaries of the data. So numerical summaries is also there, and what you can see is that box plot is also there. So what's the question? Compare the distribution of overall rating for Apple and Samsung. So we have to compare. So what is the three parameters on which we have to compare? First is the shape. Okay, so for shape means where they are skewed. So what can you tell about Apple and Samsung looking at this box plot? See, there are two outliers here.
Yeah, the Apple one has a higher average rate. Has a average has a higher Q1 and Q3.
First of all,
Has
we'll
has a high,
comment about shape. Okay, first shape. Okay. So what you
has
can
a
see,
higher overall
shape
rating.
means there are two outliers on the left, two outliers on the left, so it
Yeah.
will be skewed to left. Yes or no?
Yeah.
Okay, and here there are no outliers, so it will be
Roughly symmetrical.
roughly symmetrical. Roughly symmetrical. So what on next we have to tell is about the
Apple has a higher minimum.
yes to the left. So outliers, there are two outliers in Apple tablet distribution overall rating that's on the range. I think so. If we compare, it's around 76, and between 70, for example, if we take the exact value, 71, 72, 73 is here, 74, 75. And then if we take exact of this, that's 76. 73 and 76 are outliers. The Samsung tablet distribution has no outliers. So we have commented about the outliers. So you can see from here also, you can tell that the mean is higher for Apple, not for Samsung. But why mean is higher for Apple? Because of the outliers. Yes or no? If we remove the outliers and
Yeah.
calculate the mean of Apple, it would be less than. Okay. So how
Yeah.
can you predict the outliers from this data also? I'll tell you. Yes, I'll take this data here. No, you have to take it from the box. Here in this table is not more clear, but in the data where there are outliers, it is generally more clear. Okay. So see here in Apple, it's coming 83. Okay, here. And the Q1 is
Mhm.
83 and the Q7 is 87. And you can see that there are data points greater than this. So there are outliers there, okay, in Apple. So this is center. The Apple tablet had a slightly higher median overall rating. See, what is the median rating is 84. The Apple has more rating. That's coming to be 84 than Samsung tablets. More importantly, about 75% of the Apple tablets had overall rating that were greater than or equal to the median for the Samsung tablets. So see here see the left side of the thing is that the rating of the Apple phones is greater than or around 75. Yes or no? Because Q1
Mhm.
for it is coming here. I'll go here in our case where we can plot things. This Apple is starting from here. Okay, from 80 or around about greater than 75. And this Q1 is for Samsung is starting for year. So what he's trying to say is that the most importantly about 75% of the Apple tablets had overall rating than that were greater than or equal to the median for the Samsung tablets. Yes. Yes, so see, the greater than median of Samsung is here, and see here most of the data set. This is 75. Q1 represents 75% of the data. Q2, I've told you, represents 50% of the data, and Q3 represents 25% of the data. If we plot a box plot, see from here onwards, there is 75% of data in front. From here, if there is 50% of data, there is median, and from here, there is 25% of data. So see exactly the ratings for Q1 year is being projected to the median of the Samsung phones. So it's 75% of the ratings are greater than the median of the Samsung phones. Did you get it, Zaid? What I'm trying to explain?
Mhm. Yeah.
Yes, there is much variation in overall rating among Samsung tablets than the Apple tablets. So you can see that there is more variability. The box plot of it is more greater and there is more variability. So standard deviation of Samsung will be more. See here. Yes or no? The standard deviation of Samsung is more. We can examine and what you practically see more things here in this example. Yes or no? So this was the thing. Now I think so we have Alhamdulillah completed the chapter. There are examples left. Oh, 1.3, and there is the
Uh,
exercise based on
I'll
it.
do that later.
Yes, you do that. We are going to solve it tomorrow. The difficult from it, this one. I'll analyze which are the difficult ones and which cover. Okay,
Mhm.
Alhamdulillah, we have wrapped up the chapter one. Yes or no?
Yeah.
So, okay. So we'll stop here today as we have wrapped up chapter one. From tomorrow, inshallah,
Mhm.
what I'll do, pick up the all the difficult sums from this chapter and we'll see it one by one in one or two class, and then we'll go with chapter two. Okay, this
Yeah,
is
okay. Got it.
chapter 2, which is there's a lot of exercises here.
Normal
You need
model,
to
bell curve,
yes, see unit 1. We are on unit 1 only, and it's chapter 2. Okay.
details, yeah.
Yeah, so this will be chapter 2 that will be starting inshallah tomorrow. Okay, so
Yeah, okay.
that's the end of the day. Okay, come on. Assalamu
Mm-hmm.
alaikum.
Walaikum salam.
Thank you for waiting for so long for the class. I
It's
slept
alright.
late at night due to some function. Okay, so it was very difficult. Okay, Assalamu alaikum. You can leave.
Walaikum salam. Allah